Okay, let's take a look at 3.1 to 3 notes, graphing reciprocal functions. So the reciprocal functions 1 over x, we have actually asymptotes, which are basically lines that we cannot cross, kind of like force fields. So we're looking at something like this, and it kind of wraps around the origin there. That's kind of our center. So what's our domain here? Well, it's not all real numbers, except the domain is our x. We can't have an x of 0 because that's on that blue dotted line. We can't have that. And same goes for the range. There's a horizontal line, the x-axis, that we also can't cross. So our vertical asymptote is x equals 0. Our horizontal asymptote is y equals 0. So that kind of gives us a center of 0, 0, although it's not really the center. It's kind of where the asymptotes wrap around, though. All right, transformations. H is the horizontal shift. Plus, we go left. Minus, we go right. It's the opposite. So this is our equation. Think of x minus h as having parentheses, and then being a denominator instead of just parentheses. Or else it's pretty much the same thing of what we've been dealing with all semester, whether it's squared, cubic, quartic, it's the same idea. C. K is the vertical shift. Plus is up, minus is down, the way it should be. A is negative. The function is reflected across the x-axis. If the absolute value of A is greater than 1, it represents a vertical stretch. And if A is between 0 and 1, then it's a vertical compression. Just like what we've been doing every chapter since the beginning of the year. Now, our vertical asymptote is always going to be x, going to be x equals h, whatever that is, whatever the thing with the x is. Horizontal asymptote is y equals k. So h is our x value, k is our y value, and that's basically what we're doing. The reciprocal parent function is translated 4 units to the right, 3 units down, and reflected across the x-axis. Write an equation to represent the new function. Identify the asymptotes. Okay, so we'll call this f of x. We know we're going to have a denominator because it's a reciprocal function. We know we have an x down there. So it's translated 4 units to the right. So that'll go with our x, because that is our x-axis that we're going on. And instead of plus 4, it's actually minus 4, the opposite of what you would think. 3 units down, well, that's outside of the fraction. So it's, not plus, but minus 3. Right, then reflected across the x-axis. Just means our a value, which is in the numerator here, is negative. It can be any number we want. It could be negative 42. It doesn't matter. Then when we find our vertical asymptote, it's always going to be x equals 4. And our horizontal asymptote, y equals negative 3. And of course, those are from here. Again, the blue is opposite because it's kind of like in parentheses. Let's try a couple more of these. The reciprocal parent function is translated 7 units up and 1 unit left, then vertically stretched by a factor of 2. We'll do g of x now. Set up our fraction. We got an x there. translated 7 units up. So that's behind the function. 1 unit left, so it'll be plus 1. Vertically stretched by a factor of 2, well, that's our a. So that's it. That's our whole function. Our vertical asymptote is what our x equals, which is -1, opposite of what's in the denominator. And the horizontal asymptote is y equals 7, what's chilling by itself after the fraction. Right, we got one more of these. We have the reciprocal function has a vertical asymptote located at x equals -2 and a horizontal asymptote located at y equals 5. Write an equation that could represent this function. So we can put, for the most part, anything we want besides 2 spots. So if the vertical asymptote is at x equals -2, that means it's plus 2 in our equation because it's the opposite. Now, it doesn't say if there's a stretch, compression, or reflection. So it doesn't matter what this is. I'm going to make a smiley face. And located at y equals 5, well, that would just be plus 5. So it's really just about h and k, setting up our boundaries, and then filling in the rest. Oop. I guess we don't need to do the horizontal vertical asymptote because we already have them. So now we're going to graph some. F of x equals 1 over x minus 2. So our domain is all reals except 0. Because if x equals 0, we'd be dividing by 0, and we can't do that. Or another way to think about it, that's x minus 0 in our denominator. So our vertical asymptote is at x equals 0. Our range is all real numbers except, well, our horizontal asymptote is y equals -2. So it's all real numbers except for -2. So we create asymptotes at x equals 0 and at y equals -2. Just kind of wrap around. I'm not going to be too picky about what points. I'm more concerned about the right placement. That's number 1. Number 2, we could add a plus 0 at the end so that we have our k. Our vertical asymptote is x equals -3, and our horizontal asymptote is y equals 0. So our vertical asymptote at x equals -3 is there. Y equals 0 is really our x-axis. So our domain is all reals except, well, -3, because it can't be that. That's our force field. Let's make this a little bit smaller. Likewise, the range is all real numbers except 0, because that's our horizontal asymptote. And again, just make sure it kind of wraps around those asymptotes. I'm looking for the asymptote to be in the right place and that we have our curves in the right quadrants, if you will, of our asymptotes. All right, number 3, we got to do a little bit more here. Again, we could have -0 down there. So our vertical asymptote is x equals 0. So we can graph that. That is our y-axis. Then we look at our horizontal asymptote, it's y equals 1. And that is up 1. And we have our asymptote. So, oops, we want to write our domain and range. Again, it's going to be all reals except whatever our our vertical asymptote is. So except for 0. And the range will be all reals except what our horizontal asymptote is, 1. But something else is going on here. We have a negative. We also have a 4, so it's a vertical stretch. What the heck? By 4, but also it's a reflection. So it flips upside down. So instead of being the upper left or the upper right, bottom left, it's now the upper left, bottom right. So it just flip-flops. Number 4, vertical asymptote is x equals -4, and our horizontal is y equals -2. So x equals -4. There's our vertical asymptote, y equals -2. There's our horizontal asymptote. So our domain is all reals except -4, and our range is all reals except -2. And it's always going to be the case that whatever our vertical asymptote is, our domain is going to be everything except for that. And same thing for our horizontal asymptote. It'll be all reals except for that number. And we don't have any stretch or anything like that or reflection. So it's just going to be in the same bottom left, upper right quadrants. Wow, that's pretty horrible. Make them a little bit more round than what I just did there, but we get the idea. All right. Vertical asymptote, x equals 2, y equals -5. Again, just from here and here. But this is the opposite. So we got all reals except +2, and our range is all reals except -5. So we got asymptotes there at x equals 2 and y equals -5. There is a stretch, but it does not say anything about a reflection. It's still up this way, and this way, and a little bit this way. One last one to go. Our vertical asymptote is x equals 5, and our horizontal is y equals 3. Our domain then is all reals except what x can't be, which is 5. And our range is all real numbers except what our horizontal asymptote is, 3. So we have asymptotes at x equals 5 right here, give or take. Pretty horrible straight line. And y equals 3. So now we just need to draw in our graph. But wait, we have a stretch by 2, which we're not going to really worry about, but we do have a reflection over the x-axis. So instead of upper right, lower left, it's upper left, lower right. And that would be our graph. And that's 3.1, 3.2. There you go.